Hello again. Let us use another example for partial derivative, and this time we're going to be using a Cobb-Douglas production function. So Cobb-Douglas production function shows you that how much output you can get for different combination of two inputs. Let's say we have a capital and labor. These are our two outputs. Suppose our Cobb-Douglas production function looks like output is equal to k to the power of 1.5 and L to the power of 1.5. So we have two argument, which is capital and labor. And we are going to calculate or evaluate this function and find a marginal product of labor and marginal product of capital. Now, the question I have for you, if someone could please answer this question and then compare your answer if you're right or not. I'm going to ask the question, pause the video, and then write your answer, and then come back and listen, see if you're right. Can anyone tell me mathematically what is the marginal product of labor? Can anyone, please? If your answer is that mathematically speaking, marginal product of labor is the partial derivative of a dependent variable with respect to partial derivative of your independent variable. If that was your answer, then you're right. Again, the question was mathematically speaking, what is the marginal product of labor? Then the marginal product of labor is the partial derivative of a dependent variable with respect to independent variable. And of course, in this function, you know that Q is dependent on K and L because level of K and L determines what level of Q would be. Now, so that's our function. Economically speaking, this is the rate of change. Delta Q over delta L is the rate of change of Q. And what does this tell you? This tells you that the rate of change of output per unit of labor, per unit change in labor for giving value of K and L. Again, this delta Q over delta L tells you that the rate of change of output, the rate of change of output of Q per unit change in a labor for giving value of K and L. If we were to take the derivative of this function, partial derivative of this function with respect to L, please pause the video and then take the derivative with respect to L and see if you get that answer. So the answer would be that if we take the partial derivative with respect to L, then we know that K times L, both of them raised to the power of 1/2. Since we're taking this with the, we're taking the derivative, partial derivative with respect to L, we consider K as constant. Therefore, when we take the partial derivative of this L to the power of 1/2, 1/2 K to the power of 1/2 and L to the power of 1/2 minus 1 becomes minus 1.5. And the reason I say L, because L to the power of 1.5, the rules of derivative is that you bring 1.5 down, L 1.5 minus 1. When you solve this, then that is equal to 1 minus 1.5. So that's how you solve. So here we go. This is what we have, and you can further simplify this one because this is raised to the power of 1/2. Basically, this means 1 over L to the power of 1/2. So you can write it as 1/2 times K to the power of 1/2 and L to the power of 1/2. And you can further write this one as 1/2 times K over L to the power of 1/2. Now, another question for you. What K over L to the power of 1/2 same as what? This is same as K over L. So raised to the power of 1/2 or raised square root of K over L, they are the same. So that's the first part. We calculated marginal product of labor. And then now we are going to calculate or compute marginal product of capital. I'm going to have Q is equal to K to the power of 1/2, L to the power of 1/2. And then we say that marginal product of capital is equal to partial derivative of Q with respect to K. And again, when we take the derivative of this function of Q with respect to K, again, I'm just going to write it here, change of K, that's equal to 1/2 K, 1/2 minus 1, that becomes minus 1/2, and L is constant, therefore we write L to the power of 1/2. You can do the same thing we did on the previously right here. This is what we did. You can write it like this, or you can leave it the way it is. It's totally up to you. But if you write it like this, it will make more sense. Now you know that K is raised to the power of 1/2. That means that 1 over K to the power of 1/2. Therefore, that will be L over K to the power of 1/2. And this is the same as a square root of L over K. So the question is, like I asked the question before, what is delta Q over delta L? I'm not speaking mathematically, but I'm asking you in terms of economics. Partial derivative of Q, a dependent variable, with respect to independent variable. This is, what does this tell you? This tells you that the rate of change of output per unit change of capital for giving value of K and L. Again, delta Q over delta K is tells you that the rate of change of output per unit change of capital for giving value of K and L. So again, taking partial derivative was the question. I put some spice and add some spice to it. And then I'm just going to give you some intuition in terms of economics as well. So this will be another different types of questions where you will be required to take this partial derivative. And also for this one, if it's an optimization problem, then you need to use Lagrangian, and Lagrangian is subject to a budget constraint. That's totally different question. I'm going to stop here, and then the next video will be a total derivatives. Stay tuned.